Okay, so this next example is finding a confidence interval for estimating a population proportion. So the University of Washington School of Medicine, they found that 750 out of 1,000 adult Seattle residents said they did not believe they could come down with a sexually transmitted infection. Construct a 95% confidence interval estimating the proportion of adult Seattle residents that do not believe they can contract an STI, and round the answers to 2 decimal places. So the first thing we want to do is we notice they don't tell us anything about the population. So we're going to go ahead and do some preliminaries. So let's go ahead and do part 1. And 1I is always taking the sample size and determining whether that was no more than 5% of the population. So the sample size we can see is the 1,000 adults. And we want to make sure that that is no more than 5% of, and then the population. In this case, it seems like it says adult of all adult Seattle residents. So remember, they only took the residents that were from the university, that were funded from the University of Washington. And so they only took 1,000 Seattle residents. So the population is all the adults that live in Seattle. So do you think 1,000 people is no more than 5% of all Seattle residents? Yes, I think so. Right, definitely. That's a big city. The second part is making sure that NP times 1 minus P is greater than or equal to 10, because this will give us approximately normal population, right? Okay, so the first thing we want to figure out is what is our P? Well, in this case, we're going to use the information they gave us, right? They said that 750 have the characteristic that they didn't believe they could come down with an STI. So x over n is equal to 750 over 1,000. A nice decimal that we could use. So 0.75. So this means we can use our p hat as 0.75 and then use that in our calculation. So we'll have 1,000 times 0.75 times 1 minus 0.75 and see if that's greater than or equal to 10. So we'll do 1,000 times 0.75 and then do parentheses 1 minus 0.75. And that's 187.5. And that is definitely greater than or equal to 10. So then we know the population is approximately normal. Right? And remember, the first one talks about independence. These together say, well, that means we could go ahead now and continue the process. So we want to find a 95% confidence interval. And so this means that our confidence level is 0.95. And our X is 750, right? The Seattle residents who didn't believe they could contract an STI out of the 1,000-person sample. So if we went ahead and went to the calculator and went to stat, test, and then all the way to A, 1 prop Z int, hit enter. And let's go ahead and put our values. So we had 750 out of 1,000 at a 95% confidence interval, and then calculate. And so I'm going to just drag this over pretty quickly. Okay, and so we can see the proportion of Seattle adults that do not believe they could contract an STI is between 72 and 78% if we round to 2 decimal places. So the numerical answer is 0.72, 0.78, rounding correctly. And how would we interpret this? So we could say that the University of Washington School of Medicine is 95% confident that the population proportion of Seattle residents, of all Seattle residents, right, that believe residents they could not contract an STI is between 72% and 78%. So essentially, we can be 95% confidence that the population proportion of all adult Seattle residents that believe they could not contract an STI is between 72 and 78%, which is kind of a lot, right? Okay. So the next example, we're going to discuss kind of working our way backwards. So a lot of the time we want to see what sample size do we need, right, in order to be within a certain margin of error. So sometimes when we have this, population proportion, we want this margin of error, which we call MO, right, to be small. Like we want to get as close as possible to this population proportion. We want the interval to be tiny, right? We want to see where the true proportion lies off of a tiny sample, right? So with proportions, it's kind of different than when we did estimating population means. So first of all, we can see that the sample size here is this nice little equation. Well, and notice we have a z sub alpha over 2, so we still have to find that little area in the right tail. Well, notice they give us a p hat, so there's a couple conditions, right? This formula uses p hat, which depends on n, the sample size, where we are trying to determine the sample size, right? So how would I find a p hat if I need n and I'm trying to find n, right? That's just like, doesn't make sense, right? So the p hat given in this formula is going to be on a previous study. So it's kind of part of the sampling distributions, right? You're taking a lot of samples to estimate the population. So you're just going to take another sample's p hat and use it on this to find a good sample size. When none is given, then we just go ahead and just use a half. We use the largest possible value of n for a given level of confidence margin of error. So if they give you a previous estimate, use p hat. If not, always use, otherwise use a half, which is simple, right? Just two numbers. Okay, so if we wanted to find the sample size for this example, let's take a look. A sociologist wanted to determine the percentage of residents in America that only speak English at home. What size sample should be obtained if the sociologist wishes that the estimate is within 3 percentage points with 90% confidence, assuming that the sociologist uses the estimate attained from the Census 2000 supplementary survey of 82.4%. So they're giving us a lot of information here, but the goal is always to find this sample size, right? So don't take your eye off the prize, right? We want to find a sample size. Okay, so let's go ahead and list everything they give us. What's interesting here is they say we want to find the sample size and that we want the estimate be between 3 percentage points, 90% confidence, and we're using a p-hat prior estimate from the census, which is a pretty good estimate, especially if it's a census. So here, our error, our E, will be 3%, right, or 0.03. Our p-hat, they gave us from the census of 82.4%, or in other words, 0.824. Okay, and our z sub alpha over 2, well, again, that's going to take a little work. So let's go ahead and draw a picture. That is always the best thing to do, right? And remember, 90% confidence says that you're trying to find this margin of error from the population proportion. So here's P, and then here is the lower bound and then upper bound. And then here's the margin of error, and then here's 90% confidence interval, right? So if it's a 90% confidence interval, what is left to be in the right tail? Well, there's 10% left, right? From 90%, because that equals 100, and it's split into two tails. So if we split it into two tails, we know there's 5% in each tail, which means that the z-score here will be z sub alpha of 0.05. So let's go ahead and put that in the calculator in inv norm. The area will be 0.05, comma 0, comma 1, because remember the z-scores on a normal curve, z is equal to 0 in the middle, and the standard deviation is 1. Okay. And then we can either put left or right, because notice that left or right, there's still 5% in the tail. So I'll use right just because that's what we've been using. So let's go to our calculator and find the z sub alpha over 2. So in this case, it'll be z sub 0.05. And then we go to second vars, which will give us distribution. Inv norm is number 3. And we'll go ahead and put 5%, so 0.05, 0, right, 1 for the standard deviation, and then right for the tail, and we'll hit paste and hit enter. So this will give us 1.645. Okay, and so we get this z-score, and we'll round to 3, so 1.645. Okay, I think we have everything for the formula. So recall now that, let me draw a little. And so n will equal p hat times 1 minus p hat times the z sub alpha over 2 over e squared. So the p hat is going to be the 0.824 times 1 minus 0.824 times the z sub alpha over 2, which is 1.645, over the margin of error of 0.03 squared. And don't worry about the formula, just put it all in the calculator. So if I move the calculator over here, we'll get 0.824 parenthesis 1 minus 0.824 times parenthesis 1.645 divided by 0.03 and then square it. So it should look like that. And then hit enter. So we have 436.04. And then before I answer, I want to make sure that I understand what my sample size is. So my sample size is the percentage of residents in America. So residents, can we have 436.04 residents? No, right? So we need to either round up or round down. In this case, I would round up to 437 residents, right? Or 436 residents. I would try one of those. We always round up because if we have zero point zero 0.04 residents, we usually have the whole house, especially if they're part of the census. So what does this mean? It means that you would need we need, or the sociologist needs, right? A sample size of 437 residents, or 436, which one, in order to be within 3 percentage points with 90% confidence. And of course, we could write more for, that only residents in America that only speak English. But the idea is this, like we would need a sample size of, we would have to survey at least 437 residents in order to be within that 3 percentage points of 90% confidence. So the z-score is the only one we'll have to like kind of think about, but I encourage you to like draw the curve and the interval and then split it like do by picture, and that way this kind of becomes directly from the picture and pretty simple to calculate. And again, you're not really calculating, you're just kind of inputting information into the calculator.